What's up, everybody? Welcome to another video, and I hope you're ready to flex those brain muscles. In this video, we're going to talk a little bit about the polar coordinate system. So we're going to plot some points using polar coordinates, and then we're going to convert some points from rectangular to polar and vice versa. So I hope this video helps anybody taking pre-calculus, or maybe you're taking Cal 2 and you need a refresher on this stuff. Hope this video helps. Let's go ahead and jump right into it. So let's jump into something that we're definitely familiar with by now, the rectangular coordinate system. This is by far the most popular coordinate system that we use, but it turns out that it is useful to learn polar coordinates because when you get to Cal 2, you're going to see it's really useful for a lot of things, integrating certain shapes and that sort of thing. We're going to use it a lot, so it is important to know this stuff. But right now, let's look back at the rectangular coordinate system where we have an x and y axis, and we plot points of this form, x, comma, y, where x represents, let's see, I guess it would be the signed distance from the y-axis, signed meaning it could be negative or positive, and then y is the signed distance from the x-axis. This is how we plot points. We're all familiar with this. Now we're going to introduce polar coordinates. So in polar coordinates, we don't have two axes. We have one. We call it the polar axis. And we have a pole, which is like the origin, and then a polar axis, which is sort of lined up with the right side of the x-axis in rectangular coordinates, but now we're dealing with polar coordinates. So we're going to write, let's see, polar axis, okay? And instead of x comma y, we have r comma theta. This is how we plot points in polar form, r comma theta. R, well, the absolute value of r is the distance from the pole to the point, and the reason why I say absolute value is because now we do have this notion that r can be negative. Okay, and I know if you've done a lot of trigonometry, you probably have it ingrained in you that r is always greater than 0. Well, now we do have that notion of r being less than 0. We're going to look at an example in a second. But r, the absolute value of r is the distance from the pole to the point, and theta is the angle that takes us to the line formed between the pole and the point. So let's say the point we're looking at in polar coordinates is here. So this is the line formed between the pole and the point. So our angle theta would be this angle there, whatever angle takes us to that line, and our r would be this distance. And that would be how we could express that point in polar coordinates, would be r1, if this distance is r1, and theta 1, if this angle is theta 1. So this is the point r1, theta 1. Hopefully that makes sense. And the reason I like to relate these rectangular coordinates to the polar coordinates is to see that it's really not as complicated as we make it when we're first learning this stuff. And I really recommend you think back to your knowledge of trigonometry and use that, because it will come up from time to time. You will be using tangent inverse, and you'll be using Pythagorean theorem and all kinds of stuff we've learned in the last few sections. So definitely don't forget that stuff. And yeah, let's go ahead and see if we can plot some polar points. Let's see if I can give you a polar point and you can plot it. So these are polar coordinates of the form r comma theta, and we're going to practice plotting some points using polar coordinates with these three examples. So at this point in the video, no pun intended, at this point in the video, I encourage you, pause the video, try this on your own, then press play if you want to check your answer. So let's go and dive right into it. What I like to do is start with the angle. Look at the theta first, and then use that first, and you'll see what I mean once I do an example here. So here's my pole, here's my polar axis. I'm going to use my theta, because remember, that's the angle that takes me to the line formed between the pole and the point we're looking at here, right? So this angle theta is going to take me to right about here, 5 pi over 6, somewhere around there. It's not perfect. And then my r just tells me how far I'm going to go along that line. So in this case, I'm going to go 1, 2, 3. So this is my point right there. And this angle is 5 pi over 6. That's my angle theta there. Perfect, right? Not too bad. All right, let's look at our next example. Now we have a theta that is negative, but this is nothing different. If we know a little bit about trigonometry, we know that positive thetas, we move counterclockwise. Negative just means we move clockwise. Same thing here, same thing. So nothing new there. We're going to look at our pole, our polar axis here, and instead of moving counterclockwise, we're going to move clockwise by 5 pi over 6. So we're going to move clockwise this time all the way up to here. Let's see, so we're looking at something right about here, and we're actually only going a length of 1 now. So if this is 1, then that's my point. That's a length of 1, and this is an angle of negative 5 pi over 6, and we're good to go. Not too bad, once again, right? And I guess you could label this 3 if you wanted to, but I used the tick mark, so I made it pretty clear there. Now this is when it gets a little tricky because our r is negative, all right? But again, look at the angle first. That's what I like to do. Look at the angle first. So here we're going to draw our polar axis. That angle pi over 4 is going to take me right about here. But now look what I'm going to do. Instead of going 2 tick marks toward the terminal side of that angle, right? Remember we call that the terminal side. That's the line formed by the angle, basically. We're going to go 2 in the opposite direction. That's what that negative tells us to do. And what I mean by opposite is we're going to rotate around essentially another pi. If you want to think of it that way, you can think of it that way. 180 degrees around and go the opposite direction by 1, 2. Okay, so this is actually that point we are looking at. And what's another way you can express this point? That's the cool thing about polar coordinates, is with rectangular coordinates, if you change the x, it's a new point. If you change the y, it's a new point. Here we can actually express the same point using different coordinates. Pretty cool, right? We could express this same point as, let's see, positive 2, but then instead of going to pi over 4, we'd have to wrap all the way around 3, is it 3 pi over 4? No, 5 pi over 4, sorry. I'm a big dummy. I gotta add pi. 5 pi over 4. And that is actually the same point. So different coordinates, but takes us to the same point. So pretty cool, right? We can also do what? We can wrap around another 2 pi. We can just add 2 pi to this, same point, subtract 2 pi. But in general, I think what you can do is if you have a negative r, you can make it a positive, and you can add pi to the angle, and it will take you to the same point. So that's a pretty cool little trick if you want to do that. But I like this method. Look at the angle first. Then, depending on if the r is positive or negative, you're going to move the opposite direction or the same direction. But hopefully this makes sense. All right, so now we're going to practice converting some points from polar coordinates to rectangular coordinates. So again, we're taking points that are of this form r theta and converting them so they are of the form x, y. Luckily, we have equations that directly relate x and y to r and theta. Those equations, believe it or not, are actually our definitions for our trig functions, sine, cosine, tangent, etc. So remember, sine of theta, the sine of an angle equals, some of us think of it as opposite over hypotenuse. Y over r is how we usually refer to it. Opposite over hypotenuse, same thing, just a different way of thinking about it. And then we have cosine theta equals x over r. Okay, so if we do a little bit of manipulating, we can get all the stuff with r and theta on one side by itself, and then we literally have, from this equation, we have y equals r sine theta, and from this equation, we have x equals r cosine theta. So if we have r and we have theta, all we need to do is plug in r, plug in theta, we have y. Plug in r, plug in theta, we have x. It's that simple. So converting from polar to rectangular coordinates, when we're just dealing with points, very simple, very straightforward. And points like this actually make it even easier because I claim that you don't even have to use these equations for something like this. And that's because of this pi over 2 here. And I'll show you exactly what I mean. Let's just plot this point real quick and we'll see exactly what I mean. So our polar axis, pi over 2, we're going up by a length of 1, 2, 3, boom. There's our point. Where in our rectangular coordinate system is that going to lie? Well, since that pi over 2 angle is there, we know it's going to be on the y-axis. So actually, in rectangular coordinates, we're just going to be 1, 2, 3 up on the y-axis, 3 units up. That's simply the point 0, 3. We converted this point from polar to rectangular without using any kind of an equation. Okay? So the reason we were able to do that is because this angle, the terminal side of this angle, took us to where we were on one of the axes. So which angles will do that? Well, multiples of pi over 2. So pi over 2, pi, 3 pi over 2, 2 pi, etc. You can go the opposite direction. Those kind of angles are really easy to deal with. We can simply just sketch the polar coordinate in the polar coordinate system, do a quick sketch, plot the point, and clearly see what it's going to be in rectangular coordinates. But let's say you didn't notice that. Let's say you didn't notice that, you wanted to use these equations, that's fine, these will work as well. And let's go ahead and prove to ourselves that these will work. I may have to do a little bit of erasing, but I'll leave these two formulas here. So now we're going to plug r and theta into y. Remember, our hypothesis is that we're going to end up with the point 0, 3. So let's maybe write that off to the side here. That's what we think we're going to end up with, but let's check for sure. So let's first get our x coordinate. Let's see if this is going to end up being 0. So x equals 3 times the cosine of pi over 2. The cosine of pi over 2 is 0. 0 times 3 is 0. X equals 0. We have confirmed the 0. What about the 3? Let's see. Y equals 3 times sine of pi over 2. Well, sine of pi over 2 is 1. 3 times 1 is 3. Confirmed. So this indeed is this same point converted to rectangular coordinates. And as we can see, when we're dealing with pi over 2 or multiples of pi over 2, we can simply just plot the point and go off of the graph of that point, if that makes sense. But again, these formulas, they will always work. So if you miss that and you just go to these, it really wasn't that much extra work, actually, now that I think about it. An extra maybe 30 seconds, but it depends how quick you are. I'm pretty quick with these guys here. If you're not as quick as me, then it may take a little longer. But let's go and move on to part B. Let me erase this scratch work here. This we said converted to 0, 3. So now let's look at part B. So now we have r is -2. Theta is 2 pi over 3. This isn't one of our pi over 2 multiples. So we can sketch it still, but I think we're going to have to use our formulas at the end of the day. Let's see. Polar axis here. 2 pi over 3, that's going to take us somewhere over here. But that -2 is going to actually move us backwards. 1, 2, somewhere here. And the reason why I like to plot these points before I convert them is because if I end up with some x that's like negative and some y that's positive, I know that's wrong, right? So basically I plot the point and I kind of compare it with what I end up with from these formulas just for peace of mind, just to confirm that I am right. And what we can expect from this, if we imagine sort of laying our y axis over here and imagine that as our x-axis, we can expect this point in rectangular coordinates to be in the 4th quadrant. So expect to have an x that's positive and a y that's negative. So let's confirm if that's what we get. But hopefully that makes sense why I do that. Maybe it's a little OCD, maybe you think it's extra work, then don't do it. Do it whatever way you prefer. So let's see, our x equals -2. X is cosine of 2 pi over 3. So now I need to remember my trig exact values. Let's see, cosine of 2 pi over 3. Off to the side, I'm just going to write that angle again. That's a pi over 3 reference angle. So it's going to be negative because it's cosine, right? Yeah, it's cosine in the 2nd quadrant, going to be negative pi over 3 reference angle. That's 1/2. -1/2. So that equals -2 times -1/2, which is actually, I think, going to simplify to 1, right? The 2's will cancel, the negatives will cancel. That equals 1. So our x coordinate is 1. Let's see what our y is. Y equals -2 sine of 2 pi over 3. I know the sine of 2 pi over 3, since we're in the 2nd quadrant, it's positive. We have a pi over 3 reference angle. I know that gives us a √3 over 2. √3 over 2. The 2's are going to cancel. I'm left with -√3. So did we get what we expect? Yes, something in the 4th quadrant. Positive x, negative y, exactly what we expected. So this we converted to, let's see, 1 comma -√3. Sorry, it's a little crowded in there, but hopefully that makes sense, and hopefully this lined up with the work you did when you paused the video and did it on your own. Let's go ahead and convert the other way now. All right, so we're going to finish off the video with a couple of examples of converting points from rectangular to polar coordinates. So now we're going the opposite direction that we did in the last couple of examples. So we are given points of the form x, y, and we are trying to find r and theta. Hopefully that makes sense. So these were the equations that were really useful to us going from polar to rectangular. But looking at these, you can quickly see that these aren't really that useful going from rectangular to polar. And the reason why is because, again, we're given x and y. We're trying to find r and theta. Each of these equations has 3 variables. 2 of them are unknowns. So these aren't going to be very helpful. You could maybe pause the video, take these, do some substitution, manipulate them. If you want to do that, go ahead. But I'll go ahead and tell you some equations that are a lot more helpful. And the equations that we're going to use from going from rectangular to polar are Pythagorean theorem, first of all, x squared plus y squared equals r squared. That's going to be really useful, as well as our tangent function, because that involves y and x, which we're given both. So the tangent inverse of y over x equals theta. Remember that this value that's going to give you, especially if you use a calculator for this, is going to be between negative pi over 2 and pi over 2, and that is because of the range of tangent inverse. So we definitely need to keep this in mind, and this is why we always need to plot the point before we just go about trying to convert it to polar. Especially if we're just relying on these formulas, we can run into some trouble because of this tangent inverse function. You'll see what I mean through both of these examples, really. So first we're going to plot this point in rectangular coordinates. So 1, 2, 3 in the negative direction. Let's see, our y is 0, so we're actually on the x-axis over here. So we can quickly see what our r is going to be, and our theta as well, really. And this is one of those examples like we saw with going from polar to rectangular. We have those same kind of examples from rectangular to polar that sometimes you end up graphing it, you plot the point, and then you realize immediately how you can convert it to polar without even having to touch any of these equations. This is one of those examples, and in general, from polar to rectangular, remember it happened with those multiples of pi over 2. From rectangular to polar, it's going to happen anytime you have a 0 in the x or in the y, because it's going to be on one of the axes. You're going to know that the theta is either pi over 2, pi, 3 pi over 2, etc. Hopefully you get that idea by now. So here we can simply just convert this without using these formulas and say that our r is 3, because remember, that's the distance from our pole to the point. That's going to be 3, and the angle that can take us to that line formed between the two is pi. So we can simply convert this to 3 comma pi. But if you don't believe me, I challenge you to pause the video, try these formulas, see if you can get this. The trickiest part is going to be with this. If you end up using a calculator, this tangent inverse is going to give you 0, and you're going to have to know to add pi because you're over here on the left side of the y-axis. And we're going to see that through the second example, but for now I'm just going to leave this as is. Again, I challenge you to pause the video, think about this stuff on your own, but we're going to go ahead and move on to B just because I don't want this video to be 30 minutes long, okay? So with B, we are going to use these formulas because we can see that once we graph it, it's not so obvious. We're going here to -1, up here to +1. This is our point. So we're looking for this r that goes from our pole to the point. We're looking for that r, and it's not immediately clear, so we can use Pythagorean theorem. And again, that's where the Pythagorean theorem comes from, because from the point to the pole, it always forms a triangle, where our x is one of the legs and our y is the other leg. Should look very similar to the trig stuff we studied before. So r equals, I'm just going to write it all under a square root. Essentially, I took this equation and square rooted both sides. So our r equals -1 squared plus 1 squared, which equals the square root of 2. Okay, so our r is the square root of 2. We are good to go there. Now we need to find our theta. This is really the only tricky part. So the tangent inverse of y over x, that's just -1. And if you use kind of more of your intuition, you can see that this is going to be 3 pi over 4 by looking at the point graphed, and that's why, again, it's really helpful to plot the points. But if you punch this in a calculator, the problem is you're going to get -pi over 4, okay? And that's because of this range that we've restricted this tangent function to, right? -pi over 2 to pi over 2. So anytime you use a calculator, you could potentially get the wrong angle, right? So really you could just notice that, oh yeah, this is because of the restricted range of that inverse function, and just add pi to this. Or you can just look at this and think, okay, the tangent of what angle gives me -1? And that angle has to be between pi over 2 and pi. You can think of it that way. So either way you want to do it, if you want to rely on the calculator, just make sure you're paying close attention, because once you get this value, it's not necessarily set in stone. That value, you got to compare it to the quadrant that your point is in. But if you want to just look at it and think, okay, the tangent of what angle gives me -1, you can do it that way as well. Just opening up to you to pick whichever way makes sense for you, but hopefully it makes sense why this -pi over 4 is not correct and why I need to add pi. You got to think back to when we learned about these inverse trig functions. So it turns out that my theta equals this -pi over 4 plus pi. That gives me 3 pi over 4. And that my r is the square root of 2. So once I convert this point, it becomes square root of 2, comma, 3 pi over 4. Hopefully this helps. Hopefully this video makes sense. Any and all questions, leave below. I'll try to answer all of them. Most importantly, keep flexing those brain muscles. See y'all later.